Welcome everyone. So in this session we are going to solve the problem remove duplicates from sorted array part 2, part 2. So I would recommend you to watch the remove duplicates from sorted array part 1 for better understanding. So let's try to solve this particular problem. You are given an integer array which is sorted that have duplicates. Example, let's take example nums equals 1 1 1 2 2 3. What you are supposed to do is there the duplicates are allowed at most one time. That means if you are going through this one duplicated once, but the second time it's getting duplicated, it should be removed. 2 it's fine, 3 is also fine. So the nums will be manipulated as 1 1 2 2 3. Remaining can be anything. Let's take some other example to understand it. Suppose it is nums equals 0 0 1 1 1 1 2 3 3. How this is going to get modified? So we can see 0 0 duplicated only once, 1 1, these two ones will be removed, and 2 3 3, this way it will be modified, and we have to return the length of these many elements. Here in this case the length of these many elements with at most duplication once. So this is what we need to return. How can we solve it? We can solve it in various ways. So let's try to approach in various ways. Solution 1 will utilize hash map, and that means dictionary and a new list. So while it is traversing, this will record the frequency of repetitions, and the moment it will keep on storing these elements in a new list until the frequency get increased more than 2 times, and after that we can manipulate this nums. So we'll understand it once I'm going to code it. Let's start with the class definition. So class solution, what's the method inside this class? Method is remove duplicates, and the arguments are nums is given, which is a list of integer. What else? Nothing. You are expected to return another integer. So what I need is that a dictionary, let me name it as frequency, and a new list to store it. Then I'm going to traverse it. For num in nums, the slight mode for num in nums, frequency going to update that hash table. Frequency of num is equal to frequency dot get num, 0 plus 1. This will keep on adding the frequency of occurrence in this dictionary, in this particular dictionary. So at any moment like if frequency of num is less than or equal to 2, that's the condition, then we can keep on appending the new list dot append num. This way we will be having duplication at most 2 times. So once this is done, we can manipulate this nums the way we want it. We just need to iterate through the frequency, we have to iterate to the new list. For that, for I in range of length of new list, then nums of I will be replaced by new list of I. By this fashion, the array will be updated in a way we wanted, and what we expect to return is nothing but return the length of new list. That's it. So what is the time and space complexity? So here we are iterating only once, here again once. So time complexity is order of n. What is space complexity? We are utilizing an extra dictionary, an extra list. So an order of n is the space complexity. Can we make it better? Yes, we can make it better using 2 pointer methods. Let's see the solution 2. Solution 2. To explain solution 2, I am going to copy this example. Let us copy this example and substitute here. For that, I am going to keep one pointer k here, another pointer I here, and I will be traversing here. As I traverse, we will check whether the nums of I not equal to nums of k minus 2. If this happens, then we will be substituting that particular element I in the k location, and k will be advanced to one location here, and at the end k will be the one thing which we need to return, just similar to what we have seen in the remove duplicate part 1 problem. So we just need to write like that. So let's solve it straight away. Let me copy the class and method definition. Copying it. Yes. So here k equal to 2, I am going to fix it. And one more thing, if the length of nums is lesser than or equal to nums itself, it doesn't matter whatever it holds, we can just return that length. That is an edge case. So we can write if length of nums less than or equal to 2, in that case just return length of nums. We don't need to move forward and do anything. And we are going to iterate I. For I in range of, where we are going to start? We are going to start from the second indices, as I pointed out earlier, and we will go up to the length of nums. And if nums of I not equal to nums of k minus 2, then we are going to substitute the k location, nums of k, with nums of I this will make sure this particular thing will make sure the duplication will happen only maximum one time, and one element will only occupy two times, because we are advancing the k also here inside, and we will advancing k here after doing this thing, k plus equal to 1. So this will take care of everything. So once this is done, we just need to return that k, return k. So by this way, this particular nums will be modified in this fashion, and the k we are counting. So this pointer we are going to return. So what is the time complexity? So time complexity, we are just iterating it once. So time complexity is order of n. Since we are not utilizing any extra space, space complexity is order of 1. So with that, we explained this problem and explained it using one solution 1 and a better solution 2, that this is done. So thank you.